All right, today's lesson, we're going to be talking about area of polygons. So this is section 10.3, talking about area of polygons. When we're talking about perimeter, I used a fence example for like fencing in horses or animals of some sort. When we're talking about area, it's a little different. So for instance, let's say you were a rancher and you wanted to plant some amount of corn. You need to know how much area you have to figure out how much corn you can produce. Okay, that's not a very good square or rectangle. So if you got a bunch of corn in here, and you need to know, well, if you have 8 yards, it's a really small patch of corn here. So we got 8 yards on this side and maybe 7 yards on this side. We need to figure out how many square yards of corn that is. And so we multiply it together. We got 56 square yards of corn. Something that might be more interesting for you guys, well, we have a gym we're going to be building here on campus in the next few years or something. And so on this gym, we're going to need a floor for the gym. So if we're looking at a picture on the top of the gym here, we're going to want a little basketball hoop. Here it's got a backboard. Maybe we'll have a volleyball net in the middle somewhere that we can take down. Floors of gyms are often made of wood. And so in order to figure out how much wood we need for the floor, we need to figure out the area of the gym. And maybe it's 100 feet long by 50 feet wide. And so we need to figure out how much wood to buy. And in this case, 100 times 50 would be 5,000 square feet. Or you could write 5,000 feet squared. The reason we use square units, now notice, remember in perimeter we used just regular units like feet or yards or inches. The reason we use square units for area, I'll use a smaller example here. Let's say we had a rectangle that was 2 units by 3 units. What we're actually doing is making, those aren't perfect squares, but you get the idea. We're making up how many squares of a specific unit size can fit in this shape. So in this case, we're probably looking at, depending on the size of your screen, we might be talking about centimeters, so square centimeters. So how many? 1, 2, 3, 4, 5, 6 squares. So 2 times 3 equals 6, and we'll call them centimeters. 6 square centimeters. So again, make sure that when you're talking about perimeter, you're using regular units, and when you're talking about area, you're using square units, because area is how many squares of a certain size unit can fit into your shape. Also, if you were carpeting your room, or you needed a rug for your room, you'll need to know area. You need to multiply the length times the width of your room and go to the rug store, the hardware store, and tell them how many square feet or square yards of carpet or rug that you need for your room. Now there's a couple different formulas that we need for this section. We already talked about the area of a rectangle. I'll just say R. So area of a rectangle is going to be length times width. So we have length and width. You'll need to know the area of a square. Okay. The area of a square actually can go by length and width as well. But the special thing about a square is the length and width are equal. So oftentimes what we just say is side times side, or side squared for a square. So you could say length and width if you wanted, but most people just say side squared because the length and width are the same. You're going to need to know the area of a parallelogram. So I already used R, so the P will say parallelogram is base times height, which is slightly different than length and width. The base is kind of like the length, and the height is kind of like the width, but it's different in kind of an important way. That looks alright. Let's get rid of that. So here's the base, and a lot of people want to use this distance as the height, but it's not. Height of a parallelogram, or a triangle when we get to that, is always done from a 90-degree angle off of the base. So you got to make sure you're measuring that, because this distance here is going to be different than that green distance I put up there. The green is actually going to be longer than the red there. So the height has to be the red. So I always put the H on the inside there. Now, you could also measure from the outside if you wanted, as long as you make some imaginary lines. As long as you have a 90-degree angle from where the base would extend out to where the top would extend out, that's the height. And notice the height here would be the same as this height here. So either one of these would be an acceptable thing to measure for the height. And then you just multiply those together. The reason that works is if you were to chop off this green rectangle I am tracing right here, if you were to cut that off, you could just move it right over to this empty spot, and what would you have? You would have a rectangle of length B and width H. Okay, so BH. So that's why the formula looks so similar to the formula for a rectangle, because technically they are the same. Now we need the formula for a triangle. So the area of a triangle is base times height, kind of like a parallelogram, but only half of it. Only half of it. So if we have a rectangle here, and there's lots of different ways to draw a rectangle, this is just one of them, but 1/2 base height always works, which is nice. Now you can use any of these sides for the base, not just the one on the ground here, not just the one, that's the flattest. In fact, just so you don't think that you only have to use the flattest one, I won't make a flat part parallel to the bottom. I'll just draw it something like that. Okay. It's not perfect, but that doesn't look very good at all. Okay. There we go. So nothing's parallel to the bottom of the screen, so you wouldn't know which thing to use for the base. You can use any one of them, but you have to have a corresponding height that goes 90 degrees off the base. So if we use this as the base here, we have to have a corresponding height that comes off 90 degrees that touches the opposite corner. Okay? So we can use that as B and that as H if we wanted. Or, let's get rid of that. If we had the proper measurements, or if we were measuring ourselves, we could use this as the base. And then we'd have to use this as the height, as long as it was measured off at a 90-degree angle. Okay, and we could also do it from the third side if we wanted. I think you get the idea, though. Sometimes when you're measuring the height of your triangle, you have something that looks kind of weird, like that. Okay, remember, you're always measuring from the base to that far opposite corner there, or vertex. In this case, you have to do an imaginary line extension of the base, which would come out like this, and 90 degrees up to the height, which would come out like this. So you'd have to measure the height right here. Okay, you couldn't measure it from inside because if you go off at 90-degree angles, you don't get to the top. You only get to here. So as long as but it's got to be it's got to be all the way to the top. You could do it over here, but this would just be a longer imaginary line. But you could still do it. I just did the shortest one first. All right. I am going to stop this video, and maybe we'll make a part 2 for this section.